Bismillah ar-Rahman ar-Rahim. This is Professor Arab. I will talk today about stoichiometry of precipitation reactions, section 4.7, how to solve stoichiometry problems for reactions in solutions. كيفية حل المسائل المتعلقة بتفاعلات الترسيب في المحاليل المائية. We have to follow the 6 steps below. The first one, which is identifying the species present in the combined solution and determine what reaction occurs. يعني لازم نكون عارفين شو هي المواد اللي موجودة في المحاليل المختلطة مع بعضها حتى نقدر نحدد التفاعل اللي بصير. Then we write the balanced net ionic equation for the reaction. نكتب كمان معادلة خالصة تأيونية للتفاعل اللي حصل. Number 3, from the net ionic equation, we have to calculate the number of moles of reactants. إيجاد عدد مولات المواد المتفاعلة. Number 4, determine which reactant is limiting. أيضا نحدد المحدد لنهاية التفاعل. 5. We calculate the number of products as required. Finally, we convert the number of moles to grams or other units as required. These are the 6 steps needed to solve any problems concerning the precipitation reaction in solution. Next slide, I will show you the exercise number 1, that the reaction between silver nitrate solution with sodium chloride solid. The exercise here says that how to calculate the mass of solid sodium chloride that must be added to 1.50 liter of 0.100 molar silver nitrate solution to precipitate all the Ag plus ions in the form of AgCl. يعني بدنا نحسب كمية كلوريد الصوديوم اللازمة لإضافتها حتى نرسب كل أيونات الفضة في محلول نترات الفضة حجم 1.5 لتر molarity 0.100 molar solution. First of all, we have to write down the molecular equation that concerning this reaction. Sodium chloride solid completely dissolved in water to give sodium ion and chloride ion with AgNO3 solution gives silver chloride precipitate plus NaNO3, which is soluble salt 2. From this molecular equation, we can convert it to complete ionic equation, which is Na plus, here I write it down, plus Cl minus, plus Ag plus nitrate ion will give AgCl, which is a precipitate neutral compound, plus Na plus NO3 minus. You see how in this equation we have sodium ion and nitrate anion both present in reactant side and the product side. We can cancel these from both equations to give finally the net ionic equation, which is Ag plus Cl minus to give AgCl as precipitate. The sodium ion, nitrate ion are called spectator ions. Now, how we can calculate the number of moles of silver ion? We have the volume and the molarity of silver nitrate by applying this equation, number of moles of silver ion is equal to molarity of silver nitrate multiplied by its volume of the solution. This will give us 0.150 mole. From the balanced equation, net ionic equation, 1 mole of silver ion react with 1 mole of chloride to give 1 mole of silver chloride. So the mole ratio is 1 to 1. Then number of moles of chloride is equal to the number of moles of silver ion. And also this will, number of moles of sodium chloride is equal to the number of moles of chloride ion, which is equal to 0.150. Then we convert the number of moles to a mass. The mass of sodium chloride is equal to the number of moles of sodium chloride multiplied by its molar mass. Molar mass of sodium chloride can be calculated by adding atomic mass of sodium and atomic mass of chloride ion will give us 58.45. This is from the number of moles, 0.150 multiply 58.45 will give 8.77 grams sodium chloride required. The next slide also will show us how the exercise number 2, the reaction between sodium sulfate solution with lead nitrate, lead 2 nitrate, mixed together to produce lead sulfate as a precipitate. We have to calculate the mass of lead sulfate formed when we have 1.25 liter of 0.0500 molar lead nitrate and 2 liter of 0.025 molar sodium sulfate. Same thing, we have to write the molecular equation, which is lead nitrate plus sodium sulfate, lead nitrate plus sodium sulfate gives lead sulfate precipitate plus 2NaNO3 salt. This is molecular equation, and this is will gives finally the net ionic equation. Net ionic equation is lead ion react with sulfate anion in a 1-to-1 ratio to give lead sulfate as a precipitate. We have to calculate the number of moles of lead ion, which is equal molarity of lead nitrate multiplied by volume, and this leads to 0.0625 mole, and the number of moles of sulfate anion, same thing, molarity multiplied by volume, which is equal 0.0500 mole. By applying that 1-to-1 mole ratio, then the limiting reactant is sulfate anion, because the number of moles of sulfate anion is less than the number of moles of lead cation, since the mole ratio is 1-to-1. After that, because sulfate is the limiting reactant, the number of moles of lead sulfate will equal to the number of moles of sulfate, which is equal to 0.0500 mole. Then mass of sulfate, of lead sulfate, is equal number of moles multiplied by molar mass of lead sulfate, and this gives you 15.2 gram. This is the end of section 4.7.